Okay, continuing our use of Newton's law of universal gravitation here. Now if instead of finding the attraction of the Sun and the Earth, if we find this force of attraction between the Sun and Mars, we'll use the same equation, but we need to be careful what numbers we put in. The force of gravity between Earth and Mars, so that's Sun and Earth. And by the way, that's the force that the Sun exerts on Earth, but it's also the force that the Earth exerts on the Sun. Remember Newton's third law. The Sun just doesn't notice it much because the Earth is quite a bit smaller. But the Earth would cause the Sun to have a bit of a wobble. I don't know if that wobble would be substantial enough to cause something like the tides, like the Moon orbiting Earth, but it would give it a slight wobble. And that wobble, by the way, is what's used by some astronomers to predict the presence of planets around distant stars. Planets orbiting distant stars would cause that planet to have a bit of a wobble, and that wobble can be detected when we receive the light from them. Okay, so for Mars and the Sun, we still have the same universal constant, big G. By the way, I guess I had a negative here. I technically should have a negative sign here because it's an attractive force. Not a big deal. The Sun's mass is still the same, 1.99 times 10 to the 30th kilograms. But now, the mass of Mars. I'm going to do a bracket here. On our chart, we see that the mass of Mars is 0.107. That is not 0.107 kilograms. That's 0.107 Earth masses. So, if I multiply 0.107 by the mass of the Earth, 5.98 times 10 to the 24th kilograms, this together makes the mass of Mars. So you can see Mars is about 1/10 the mass of the Earth. So this cumulative mass here will be about 1/10 of that. Mass of the Sun is still the same. Now I can find my denominator, the distance between Mars and the Sun. Now on our chart, that distance is written as 228, and the unit is times 10 to the 6th kilometers. Remember, I need meters in order to get newtons. So, in order to convert this kilometers to meters, I can call it 228 times 10 to the 9th meters, or I'm going to choose to write it as 2.28 times 10 to the 11th. You can see it's farther from the Sun. That's no surprise. And don't forget to square the denominator. Once again, I can show you how to put these numbers in. I'm going to say 6.67 e negative 11 times mass of the Sun, 1.99 e 30 times 0.107 times 5.98 e 24. And I could put this all in at the same time, but I like to get the numerator separate from the denominator. Now I have that number divided by my 2.28 e 11, and I need to square the denominator. And I get a force, not surprisingly, that is similar to the force between the Sun and the Earth, but it is smaller by a little more than 1 order of magnitude. Why is it smaller? Because Mars is farther away from the Sun, and Mars is less massive than the Earth. So my answer here, 1.6 times 10 to the 21st power, once again in newtons. Okay, next video I'm going to show you is how to find gravitational acceleration, little g, in a similar way.